Now listen.
Sir, I had one small doubt on the previous question.
रुको यार बाद में करेंगे 1 मिनट रुको. Listen. This is the hinge I am talking about. Rather. This is the hinge. Left part of it is connected to the door, right part of it is connected to the filament. There is a rod which goes through these 5 circular cylindrical hinges. Right? Are you able to visualize this?
Yes, sir.
Yes.
So what is so very special about the hinge? What is so very special about the hinge? You can see the hinge here.
Yes.
The speciality of the hinge is like this. Observe this carefully. When I am opening the door is rotating. I am not providing any centripetal force to the door. Do you agree with that?
Yes.
Yes, yes, sir.
Providing tangential force. I am pulling the door this way. How am I providing the centripetal force? I am not providing any centripetal force. So who is providing the centripetal force?
The hinge.
Hinge. Hinge is a multifunctional equipment. That's the advantage with the hinge. Second point, the door should not be scratching the floor. Door is not touching the floor. If it touches the floor, opening becomes difficult. Who is balancing the weight of the door?
Hinge.
Hinge. That means there is an NY component also.
Yes.
Yes.
Yes, sir.
And there is an NY component and there is an NX component. Ironically, the NX component value will change. How will it change here? I pull the door very quickly and I pull the door slowly. Omega will change.
Yes, sir.
Yes, sir.
Omega changes means NX is changing. The normal force which is providing the centripetal force is changing.
Yes,
Yes.
sir.
On the contrary, have a look at this. I am pushing the door into the wall. I am pushing the door into the wall. Is the door going in?
No,
No.
sir.
No.
That means normal force is towards me.
Yes, sir.
Yes, sir.
Yes, sir.
Now suppose I pull the door along with me. I am pulling towards myself. Is the door coming with me?
No, sir.
No, sir.
No, sir.
When normal force is acting away from me.
Yes,
Yes,
sir.
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 Who is providing that?
Hinges.
Hinge.
So hinge forces are multifunctional. Depending on the circumstance of the problem, ये set करना पड़ेगा.
Sir, and what does that thing on top of the door do that's attached to the very...
Slowly closes the door.
Automatic closure here. Suppose I keep it
Oh, achha.
open half, it will automatically close. That's also a hinge. Right. Now, what have we explained till now? That hinge ka NY component will be balancing the weight of the door. NX component provides the required centripetal force. Right? If I am pushing the door to the left or right, normal force. It's as simple as that. You have put in 2 rings this way. One connected to the door, one connected to the filament, and you sent in a nail through it. So now when I try to push it this way, normal force is to the right. I push it to the right, normal force is to the left. Right? Now listen carefully. The way we introduced this concept, generally you people are made to believe that NY will always be in the upward direction. Can you think of a situation where NY will be in downward direction? Can you think of a
Or if
situation?
you're like trying to lift the door from the gap
Ah,
with
sir.
the door in the ground,
With the handle, you try to pull it up.
then if you
Correct.
put
With the
sufficient,
handle, I try to pull it up.
no.
I'll give you a more sophisticated example used by JE people. Though this problem given by JE people, you can solve it without knowing what is the direction of the hinge. You people have learned buoyancy in your 9th and 10th. Yes or no?
Yes, sir.
Yes, sir.
Where does buoyancy act for a rigid body? This is a hinge and there is a thin rod like this. All forces generally we take. Now, I don't know. This is a hinge. JE people gave that the rod is floating inside this liquid. Right? Rod is floating inside this liquid. So now there can be an NX and there can be an NY. I actually don't have any idea on it. MG is in the downward direction. Buoyancy. Where will buoyancy act?
Upward.
Upward.
Upwards.
Where will it act?
Sir, on the
Center
rod.
of mass.
Center of mass.
Centroid of the displaced liquid. क्यों भाई साहब पूरा बॉडी का सेंटर ऑफ मास पर क्यों एक्ट करेगा? What is buoyancy? Weight of the liquid displaced.
Yes.
Yes, sir.
What is weight of the liquid displaced will be at the centroid of the liquid displaced.
Yes, sir.
Why will it be on the centroid of the body? It will not. So, if this length is inside the liquid, buoyancy will be acting this way. Centroid of the displaced liquid. Do you get that point? This will be taught in fluids again for you in detail.
Yes,
But now it's
sir.
quite simple and logical. Buoyancy is weight of the liquid displaced. Where will weight of the liquid displaced act?
Center
On
of
its
mass.
center of mass. So centroid of the liquid displaced. Right?
Yes, sir.
Yes, sir.
Listen carefully. J people gave you that this rod is in equilibrium. The rod is in.
Equilibrium.
Equilibrium.
Now students did not invest their energy in understanding NX and NY. Mental tension you take the torque about the hinge, finish off the problem. Take the torque about the hinge. Am I eligible to take the torque about the hinge here?
Yes, sir.
Yes, sir.
Point is not accelerating. I don't know NX, I don't know NY, neither do I know the values nor directions. Why headache? Take the torque about the hinge. Problem is solved. But out of academic interest, when we try to analyze this, NX will turn out to be 0.
So
There is
because
no
there's no other
horizontal
force to
force.
counterbalance it.
There is no other horizontal force. NX will be 0.
Yes, sir.
Now listen to NY. If really the direction of NY I have taken is correct, about the center of mass, buoyancy will also give me clockwise torque, NY also will give me clockwise torque.
Yes,
If
sir.
really the direction of NY I have taken is correct, about the center of mass, buoyancy also will give me clockwise torque, NY also will give me clockwise torque. Body cannot be in equilibrium because there is no anti-clockwise torque.
Yes, sir.
So NY compulsorily should be in the downward direction. ऐसा decide करोगे आप direction of normal force in hinge? Yes, depending on the circumstance of the problem. If I push the door inwards, NX will be this way. If I pull the door along with me, NX will be away from me. Depending on the circumstance of the problem, NX and NY का direction will be decided. अब तक तो Newton's laws we used to give you thumb rule. Tension always acts away from a point with respect to the point. Normal force is always perpendicular to the common surface area outwards. Hinge is a headache. You will have to look into the circumstances. Look at the beauty here. NY is in the downward direction because the rod is in equilibrium. I don't want this headache here. I just want the answer. JE people in the examination just need the correct answer. Take the torque about the hinge. Problem is solved. Unless they ask you for an X and NY. Now, if JE people ask you for an X and NY, then you are forced to think about all this. They didn't in that problem ask you for an X and NY. Students took the torque about the hinge and the job is done. Do you get this point clear?
Yes, sir.
Yes, sir.
Now this is a solved example in HCV in fluid dynamics. This will be taught in fluids, not to be done in rotation because buoyancy is covered there. I gave you this example only for you to understand that NY can be even in downward direction. In HCV, in that solved example, they will be least worried and bothered about the directions of NX and NY. They take the torque about the hinge and finish off the problem. They will not even talk about NX. No book will talk about that because that's of least interest for them. So bottom line, we understood that hinge forces are not self-adjusting, but they will depend on the problem.
Yes, sir.
Yes, sir.
We need to introduce the next part of it, and today I don't have energy here. The next part is important. It needs some energy level. Somebody was asking some doubt in the previous question.
Sir, over there, how did you get the omega like of the disk about its own center of mass to be equal to the omega of the entire system?
Rigid body theorem. It is fixed and hinged, right? Hinged from here to here, from the whole of the body.
Oh, okay, fine. All right, got it.
But आज की क्लास better.
अरे fine, sir, if you leave us right now, हमें भी थोड़ा time लगेगा ये वापस समझने के
So
लिए.
can you repeat that explanation for NYs downwards in the previous problem?
अब करने के बाद आप पूछोगे NY downwards. अब तक क्या कर रहे थे भाई साहब?
Sorry, so I got disconnected. I just saw the diagram, the last statement you said.
If this is the hinged rod, mg will be acting at its center of mass. Buoyancy will be acting at the centroid of the displaced liquid. Buoyancy will act at the centroid because buoyancy is weight of the liquid displaced. Where will its weight act? At its center.
Yes, sir.
So now if the rod is in equilibrium, buoyancy is giving me clockwise torque, right? About the center of mass.
Yes, sir.
Hinge force must be giving me anti-clockwise torque. If I take it upwards, that will also give me clockwise. And there is no anti-clockwise torque.
Okay, sir, understood.
I will have to continue with this in the next class here.
Okay, sir.
Today only I am recouping. Yesterday whole day I was not well. So literally brought down my diet. Now slowly recouping. I will continue with hinge forces in the next class. Next two classes will be quite heavy.
Okay.
Can you send today's recording?
It's already uploaded. 6th lecture.
Okay, sir.
No homework as on today. I need to introduce hinge forces. 2 lectures from now you will have homework.
Okay, sir.
Sir,
Okay.
but today's class was better.
Yes, we were able to understand quite a lot of it.
You will understand everything. ऐसा नहीं कि I leave you people with any particular concept which you will not understand. एक भी ऐसा चीज नहीं रही.
Sir, yeah.
When it comes to applying it to problems, you will find the difference. There we need to practice enormous number of problems.
Okay, sir. Thank you, sir. Bye.
Thank you, sir.
Bye,
Bye,
sir.
sir.
Thank you, sir.
Bye, sir.
Bye.